All right, folks. Thanks for coming back. Going to record this meeting so I can post it to YouTube in case anything groundbreaking happens. I'll just remind you that there's a bunch of web work assignments due this Wednesday, 4 to be specific, which is a lot in my opinion, especially one of them is a little bit longer. So it's just kind of the way that the cards fell. I was trying not to make any due next Wednesday because we're going to have our test next Wednesday. But if we want, the last one of these ones due Wednesday extended, I'm happy to make that happen. But, at that point, we're going to be pretty far after the video that you should have watched. So anyway, it's up to you. I guess what I'm trying to say. It'd be nice if you could try to do all those assignments by Wednesday. That would free you up to study for the test next week. But if we need the last one extended, that's okay. Let me know. Speaking of the test, so we're going to do the test next Wednesday during our class time via this, so via Google Meet probably. And I'd like to practice that on Monday in some way. So we can spend Monday talking, doing review, just kind of like a normal session. If you look at the YouTube videos, basically, there's nothing scheduled for Monday because I'm trying to leave it open as a review day. And I'd like to also sort of practice doing the test in some way, like getting yourself set up somewhere, turning your camera on, making sure that it works, sort of answering questions about how the process might work, and then maybe having you practice scanning and sending me something just to see that you can do it. Just kind of doing like a dry run of the test. And then, so we'll basically have one test and the final, and I'd like to have our final on the normal final exam day. So we were normally scheduled to have it on Tuesday, May 12th from 2:30 to 4:30. And so I'm trying to just get that information out there as soon as possible to see. It shouldn't conflict with anything else you're doing, but the end of the semester is going to be a little bit different because there's not like a final exam period. So that's what I'm thinking about the final, and more information about that later. I'll remind you there's lots of practice problems and topics for both tests on Blackboard, and that's for you to start looking through and practicing and asking questions about. So please don't wait to do that. Again, we'll spend all of Monday doing review, but I'm happy to answer any questions during these sessions that you want. So let me know. Okay, so I think I'll just basically turn it over to you. Again, no one forwarded me any questions. Let me just double check my email one more time, but I don't think I had any specific questions from anyone. Nope. About the assignments, you were supposed to watch a video on 4.1, which was vector spaces and subspaces today. I'm happy to answer questions about that specific video, or if you wanted to ask questions about past sections, that's fine too. So maybe can we start to see if anyone has any specific questions about class notes? So questions about the PowerPoint or the videos or the notes or anything about notes you want to talk about first. Nothing about the notes. Looking at the homework, I'm not sure if people have really looked at the ones for Wednesday. So again, this is completely your time to get the help that you need. And so I'm trying to sort of figure out, like, do some detective work by figuring out what your questions are, but it's obviously just much better if you just ask the questions. So anyway, if there aren't note questions, the homework questions, specific problems you want to look at. Okay, some folks are looking through their packets right now. Yeah, again, it'd be nice if before these sessions you kind of got some questions together. But if you're doing it on the spot, that's okay. I just might need to take a little more time to look at the problem and things. So let's see. Alex is saying, I don't know how to solve problem 5 of 4.1. I'm assuming you mean in web work. So let me pull up web work problem 5 in 4.1. Okay. So problem 5 of 4.1 again, if you sort of send me these questions ahead of time, what I can do is I can print out the question on a piece of paper, and then it's maybe a little more helpful that way. But in the interest of time, I will just write down the question right here. So this is number 5 and 4.1. So this is vector spaces and subspaces. And number 5 says our vector space is R2. And we have a subspace of that, or a subset. H is a subset of all lines, all points on the line 4x minus 4x plus 3y equals minus 12. And the question is H a subspace? So that's the problem. I'm going to pull out the notes real quick just so I can show you where to be looking in this note. So this is section 4.1, obviously. But what you want to do to look to see if something's a subspace is look at the subspace properties. And so let me just pull those notes out so I can point at them. So if you want to show something's a vector space, you need to show like all these things, right? There's 10 properties that show something is a vector space. If you want to show something's a subspace, you just need to show the subspace properties. And so that's a shorter list because the idea is that, a subspace is inside a vector space. And so you already know a lot of those things are going to hold, a lot of the properties of the vector space. And so you really only need to check these 3 things. You need to check if the 0 vector is in there, if it's closed under addition. So if you add 2 vectors in the space, does it stay in the space? And is it closed under scalar multiplication? So if you have a vector in the space, can you multiply it by a constant and have it stay in the space? Okay, so let's look at this one. So on this particular line, this is the line we're given. And there's a picture of it too. The picture looks like, if you look on the page, it gives you like the XY axis, and then it shows you that the line is over here. This is the subspace H. In other words, it doesn't go through the origin, right? Like if we rewrote the line, if we solved for y, most people like y equals mx plus b, right? So if we solve for y in this thing, add the 4x, divide by 3, we'd have 4/3 x plus 3. Doesn't look like that picture though, is this right? Did I write the right thing down? Oh, you divide by positive 3, so it'd be minus 4, right? So this is that line, right? This is that line right here. It's got a y-intercept of -4. It's got a positive slope of 4/3. Okay. Folks with me so far? I don't know if it's helpful to pull the question up or what. Again, if you send me this stuff ahead of time, I can print it off, but it's okay if we just walk through it. Everyone's with me. Okay, oh, Todd's with me at least. Yes. Okay, so the first question is the question, and it says, does H have the 0 vector? The 0. It says the 0 vector, but I'm writing it as the 0 vector, right? And so in other words, is 0, 0, which is an x comma y, in the set? Well, just looking at the picture, the thing doesn't go through the origin. In other words, if you plug 0, 0 into the equation, it doesn't equal -12. And so the answer is no on that one, right? It doesn't go through the origin. And so right away, it's not a subspace. So like if this was a test question and I just said, is this a subspace? You could just say the 0 vector is not in the set. And so it already fails one of the properties. And so it's not a subspace. But on this particular homework problem, I want you to go through all the steps, right? But just to be clear about that. So automatically, it's not a subspace because the 0 vector is not in it. But let's finish answering the other 3 parts. And I'm just gonna maybe go slowly here and pause a little bit to see if there are questions as we go. So the first question is 0 in there? No. The second part says, is it closed under addition? And then the question says, is it closed under addition? If it is, enter the words closed. If it's not, provide a counterexample. So show two vectors that are in the space, but that don't, the sum is not in the space. And so we could let u be 3, 0, for example, right? Because this is a solution to this line. If you plugged in x equals 3, right, this is an x comma y. If you plug in x equals 3 and y equals 0 into here, you would get negative 12. So that's in the set. And another example that's in the set would be v equals, let's do it with the other one, right? 0, negative 4. Those are both in the set because if you let y equal negative 4 right here, you'd also get negative 12, right? So those two things are in the set. They're both in H. But when you add them together, if we added them, we just add those two things, we'd get 3 and negative 4. And if we applied to plug that into the line, we don't get negative 12, right? And so if we did minus 4 times 3 plus 3 times minus 4, we get minus 12, which is minus 24. And so this is not in the set. So we took two individual points that were in the set, but when we add them together, we got something that that's not on the line anymore. And so to enter this one, you would enter, for example, these two vectors is one thing you could enter, but you can enter any 2 points that don't sum to being on the line. And you could do something very similar with this point, right? If you multiply this point by a constant like 2, for example, it also doesn't fall on the line. And so basically all the parts fail. And so 3, you could say like 2 times u, which would be 2 times 3, 0, which would be 6, 0, is also not on the line, not in H. And so all 3 parts fail. All you need is for one of them to fail, and it's not a subspace. All 3 of them fail. And so the fourth question says, is this a subspace? It's a yes or no question, and the answer is no, it's not a subspace because all parts fail. And so there are at least a couple questions like this. Let me just page through this, remind myself what's in this homework assignment. There's another one where a line does go through the origin. And so there's going to be slightly different answers for that one. There's a couple that talk about the different quadrants, but there's at least 4, 5 that kind of have this general form. You go through each part and then you answer the final question. Okay, so Finton says, as a rule of thumb, will lines never be a subspace because the close under addition rule? Yes. Unless it's a vertical line, or yeah, I guess maybe off the top of my head without thinking too hard, I think you're right. All lines might not work because of the addition thing. Yeah, so answer Finton's question, I believe so. Alex, glad you figured out that third part. I know these can be a little tricky to answer. Like I said, there's at least 4 or 5 of them that have this general form. So hopefully seeing this helps with that. And again, I'll post this video to YouTube so you can go back and maybe watch how we went through this one when you look at some of the other ones. Or we could look at another one if there's another one that people want to see. But anyway, thank you for that question. Other thoughts or questions about the notes or a specific problem that you're wondering to look at? We could sort of just talk through one of the problems if you want one sort of outlined.
4.1, 15 or 16, just a general idea how to solve it on the web work.
Sure, yeah, let me look at those 15 and 16 here. Okay, right, so I finished this section by trying to extend to some other ideas, some other vector spaces that we didn't actually see. So like in the notes, we see vector spaces in Rn, and then we also see Pn. And I think I did a quadrant example too, right? But then I didn't do like a matrix example, but I'm trying to extend it a little bit to that in the homework. So so let me just do number 15, or at least start it, and you can tell me if this is helpful. So number 15 says, it gives you a definition too. It says A is nilpotent. Oops, that's too many ENTs. Nilpotent if you can raise it to some power and get the zero matrix for some integer n. Let me just see what's 16 similar. I can't remember. 16 is talking about, oh, the sum of the diagonals being 0. So I think 16 might be a slightly bit easier. So that's good that we're looking at 15. So and so we're saying V equals set of all 2x2 matrices. And let's consider the subset, which is the 2x2 nilpotent or nilpotent matrices. And the question is H a subspace? So it's the same kind of form of a question that we looked at on the last one, just looking at matrices. And so question 1, is the zero matrix in the set H? In other words, this matrix here. So if it's in H, and this is H is the set of all nilpotent, and then you should be able to raise it to some power and get 0. Well, it already is the zero matrix, right? So 0 raised to the first power is the zero matrix. And so the first answer to this one would be yes, right? The zero matrix is part of this set. And so we get a yes for the first one. So far, we're on track for this to be a subspace. Let me know if people want to hear more about that. Is it closed under addition? The addition part is the one that, off the top of my head, I'm like, let's see what that one looks like. I don't have it worked out in my head. Let's see here. So let's pick two matrices. Let's let U and V be in H. Then that means that U raised to some power is the zero matrix, and V raised to some other power is the zero matrix. Right? That's what we know. That's what it means to be in that set. Well, what happens if we do, let's assume U plus V is in H. And let's see if we can show why that is or isn't true. Well, that would mean that U plus V raised to some other power, I'll say P, is the zero matrix. And we can write this out as being this, right? This would be like U to the P. This is actually a harder question than I originally realized now that I'm working on it. It would be U to the P, we'd have a V to the P, but then we'd also have all the intermediate ones, right? We'd have like UV, we'd have UV to the P minus, or to the squared, excuse me. We'd have like UV to the cubed. We'd have all the different combinations of U and V, right? In other words, we'd have like VU to the squared. These are matrices though, so we can't change the order, so I'd have to switch that over. Right, we'd have like all the different combinations of all the things being multiplied. And we'd want to know, does that equal the zero matrix? Right, that's the real question. I'm just going to pause there and let people maybe think about that for a second. I know that's a little bit confusing looking, right? Like if we tried to multiply out that fraction, or this, the sum, P times, we would have all the different combinations of U and V raised to the P power. And the question is, does that equal 0? And so I think the answer is like, no, more than likely this isn't going to work. Like, how are you going to ensure that all these things balance out to 0? Seems unlikely. And so based on this, I'm thinking the answer to the second one is probably a no. But in order to answer the question, we need to pick two and show that it happens. And so let's pick a really simple matrix and show that it doesn't work. So let's let U be, how about this matrix? That's a non-zero matrix, and when I raise it to the second power, I think you get 0, 0, 0, 0. And so this is in the set. And we could pick a similar matrix like this, for example, because when we square that, it also is in the set, right? But when we add them together, we get the identity matrix. And this raised to any power stays the same. It's the matrix version of the number 1, right? And so this is my intuition about it not working from this work right here led me to think about a counterexample that shows that it's not closed under addition.
That helps. Thank you.
Let me just sort of finish it off here and do the third part. The third part says, is it closed under scalar multiplication? And so I think this one actually works. Let's just see if let's just see if we can show it. So let U be an H, then U raised to some power equals 0. Now the question is, does C times U, where C is a constant, is that an H? Well, let's raise it to the power of n and find out. C times U to the nth power is going to be C to the n, U to the n. We know this one equals 0, and so we're going to get C to the n times 0, the 0 matrix, which is 0. And so that one actually worked. And so this one is a yes. And so we would enter closed, in other words. And so to kind of finish this one off, and I'm happy to pause and let people sort of think this one through for a second. We went through the 3 things. The 0 matrix is in there, and it's closed under scalar multiplication. So 2 out of the 3 things worked, but it's not closed under addition. And so one of them failed. And so the final answer would be this is not a subspace because we need all 3 of them to be true. I'll just pause there for a minute, maybe zoom out and let people take a look at the full problem here a little bit. And happy to clarify that one. That one was a tricky one. And I tried to, I know there are a lot of questions in this one too, right? There's 15 questions because there's a lot of sort of different topics I feel like in this section. And I want them to be clear. And the only way that I could feel like to make them clear is to sort of do a few examples of each type. And so that's why I'm willing to also extend this one if you want. So I would like to see like a good faith attempt at these problems before just blindly extending them. But anyway, number 16 is similar in that it's a matrix problem, but I think it's actually maybe a little more straightforward is my naive intuition about it without really looking into it. Okay, anyway, other questions about this specific problem? Now that it's up here, I'll certainly scan it in and again, post this video, but anything I can answer right now. I saw there was another question in the chat, but something I can answer about this one. I'm pulling up the other question. The other question was about 3.2 number 4. So let me pull that one up. Right. So Marcos, you did send me an email question about this one, and I had responded to your email, but let's just look at this one anyway. Since you asked. And I will pull the 3.2 notes out, but you're going to want to use, obviously, the 3.2 notes for this question in 3.2. So this is 3.2, number 4, and it says A is a matrix with these rows, V1, V2, V3, V4. So it's instead of, usually when it gives us the rows or the matrix in like rows and columns or whatever, it usually gives us the columns. This one's just giving us rows, so it's a little bit different, but that's okay. And it tells us that the determinant of this matrix is -1. And then what we need to do is we use 3.2 and we think about how messing around with the rows changes the determinant. And so I'm just trying to pull out 3.2. Give me 1 second. And you might want to also look at 3.2. while we go through this here. But what you're going to do is use the properties on the first page. So like, let me write down the first question though. So the question number part A says, what's the determinant of this? So taking that matrix, but multiplying the first row by 9. So everything stays the same, but you multiply the first row by 9, right? The difference between this and this is you multiply the first row by 9. Well, 3.2 tells us what to do when you change the rows. And so it says if you multiply a row and then add it to another row, the determinants stay the same. But if you multiply a row by a constant, then the determinant of the new one equals k times the determinant of the old one. And so in this one, our old one was multiplied by -9 in the first row. And so let me write down. So first row was multiplied by 9. And so our new determinant equals 9 times our old determinant. That's what theorem 3 says. And so our new determinant then is going to be 9 times -1. And so our new determinant equals 9 times -1, which is -9. And so that's how you're thinking about these kind of problems. I'll just start writing down part B. I probably don't want to do all these. I think once you see the idea, you'll see how to do this. So the second one says, what's this determinant? And so V4, V1, V2, V3. And then part C says, scroll down here, hold on. Part C says, what's this determinant? V1, V2, V3 plus 4, V4, V4. Right, and so this one, rows, well, you'd have to think a couple rows got switched. So it looks like you could get to this one if you switched, oh geez, you'd have to switch 1 and 4. This is kind of confusing. You'd have to switch 1 and 4, and then 2 and 4, and then be 3 and 2. I don't know. You have to think about this one. But this one, rows switched. I'll say some rows switched. And so you have to think about what the theorem says about that. And on this one, you know, rows 1, 2, and 4 stayed the same. You just multiplied row 4 by 4 and then added it to row 3. So this one is multiple of one row added to another. And so the theorem tells us what to do about that situation. So I hope that helps with that one, Marcos. I sent you a similar sort of explanation in an email. So I don't know if maybe my email didn't make sense or what, but let me know if that makes sense or if there's something else I could clarify. Anyone other than Marcos too? Anything there? Other homework questions or note questions? Anything I can help you with? Thoughts about the pass-fail fallacy? Anything you want to ask about school in general? Anything at all?
Could you maybe go over number 6 on 4.1?
Sure, let me scroll over to that one quick. You say number 6?
Yes.
Cool. So this is what I have for number 6. Yours might look a little bit different, but in general, it's going to give you 2 lines that are going through the middle, right? And so it's saying, so this is 4.1, number 6. It's saying our larger space, our vector space is R2, and H is union. Yeah, I'm just reading. Sorry, union of all points on 2 lines that go through the origin. So on the lines, again, mine says this is actually Marcos. Marcos says y equals 4x and y equals minus 3x. And so again, yeah, if we look at what those look like, it gives you a picture. There are two lines that go through the origin. So it makes like an X that goes through the origin. So it's the union of both of those things. And this one is, a little bit trickier than the other ones. Are there questions about the setup before I clarify that? So I didn't quite write this down. H isn't the union. The space we're trying to do is the union of those things. So I'll say the subset that we're looking about is the union of those two things. It calls like this one H and this one V, and then it says K actually is what it calls this one. And then it says the subset is the union of the two of them. So again, it's just all the points that are on both those lines is what the space is. And so the first thing says, the first question is that union non-empty? In other words, is there anything in there? Sure, there are numbers there are points on both those lines. And so when we do the union of them, it's non-empty. And so yes, it's non-empty. And it's a drop-down menu and the options are empty or non-empty. And so it's non-empty.
Is that question just specific to this problem, or do you check to see if it's non-empty whenever you have a union and you're trying to see if it's a subspace?
I think it's just I think it's just trying to get you to think. I don't know why that question's there, honestly. Of course it's
okay.
Yeah, that seems like a little bit of a strange part. And the first question is usually, is the zero vector in there? And the answer should be yes, because it goes to the origin. Both of them do, actually. So yeah, that first part's a little bit strange. The second part is more online here. Close under addition. I mean, the answer is no, because like if this is one point we're thinking about and this is another point we're thinking about, if we added those 2 points together, we'd be over here somewhere, which is not on either one of those lines. That's one way to think about it. And so the answer to that one's no. And just find 2 points that are in it and add them together and show it's not. So I would ask you to maybe just think about that. But I'll just tell you the answer is no. But the way you enter is you show a counterexample. What do you think about C? So I think it is actually closed under addition, or this part C is closed under scalar multiplication. Right? If you're on one of those lines and you multiply by a constant, we know it just stretches or shrinks the vector, right? And so it just stays on that line. And either one of those lines is going to happen. And so my intuition is that this is going to work. And so my guess is I think this is a yes, but maybe you should try to show it. I think that's a yes at least. And so you would answer closed, but maybe try to think about that. But then the final question is it a subspace? If sort of my thought process here is correct, we got a no. And so I think this would be a no because 2 failed. I don't know if that's sufficient or not. I was just sort of thinking maybe we could talk through the general idea. If you want me to go into more details about one of those 2 things, we could do that.
No, I think that's pretty good. I was just more confused about one, just why it was asking it in the first place. But
yeah, I think maybe it was just trying to get you to think about what the heck is it asking. And so it's asking for like all the points that are on both those things. So this U, maybe that's another thing that isn't clear, is means you union both the sets. So it means you take everything in both of them.
Yeah, I get that part. I just didn't understand why it wanted that instead of asking if the zero vector was there.
Yeah, I think my guess is when I added this one, I thought the question one was, does it have the zero vector in there? So, because the other ones do, right? Let me see. The one before that. Yeah, it usually starts by asking if the zero vector's in there. I don't know why it doesn't. Just, it's maybe an interesting thing is if you did the intersection of the two of them, it would only be the origin. And in that case, it probably is a subspace. Interestingly enough, because it would just be 1 point. But anyway, just something I was thinking about. All right, other things on your mind? This has been good. Thank you for those questions so far. Again, if you haven't looked at these sections, though, you might be a little confused, and maybe this will be more helpful later. And I would just maybe encourage you to take a look at the sections so that this is more useful for you. But anyway, I'm happy to do anything that helps. Anything else you want to talk about right now? Okay, I will post this video. I will also post these notes. I'm also around for other questions. Let me know if you need anything. Best of luck, everyone. Take care. Thanks for coming.